Okay, so I know you asked about the mole in grams and units. I what I like to do is actually kind of start from the beginning, kind of a bit, just to make sure you get understand it, because I'm not totally sure where you're at with this. And lead into maybe your question. So hopefully it'll be redundant, but hopefully it'll be helpful. So first of all, so we want to go over what a mole is. A mole is just simply a amount of things. Specifically, it's 6.02 times 10 to the 23rd items, and these items are usually atoms or molecules or ions. And we just need to I just want to make sure people understand that what the size of this number means. And so so I want to sort of relate it to other numbers. So let's take a look at 10,000. So 10,000 is 10 times 10 times 10 by 10, or 10 to the fourth. Or if you really think about it, it's 100 hundredths. Okay, so this is 100 times 100. So if you have $100 bills and you have 100 of them, you'd have $10,000. Okay, now let's look at the word a million. The number a million. A million is 10 to the 6. 1, 2, 3, 4, 5, 6. And what we exponent is 10 to the 6. But you also can think about it as 1,000. Okay, there's 1,000 right there. And there's 1,000. So a million is 1,000 thousands. All right. So if you had $1,000 bills and you had 1,000 of them, that would be $1,000,000. Okay, so if we go up to a trillion is 12 zeros. Okay, so it's this one doesn't work here. So it's going to be 10 times 10 times 10 times 10, so forth, up to 10, 12 tens. 10, 12 tens. Okay. So you can make a 10 to 12th, but you can also think about it is it's the same as saying a million. So if you had $1,000,000 and you had 1,000,000 of those, you would have a trillion. Okay, now just to talk about really big numbers. So if I were to talk about a trillion, if I were to ask somebody to write it down, 10,000. Okay, they might actually write the number down, okay, instead of the words. But if I ask you to write down a trillion, you're more than likely going to write the word and not the number, okay? And that's the kind of thing we want to look at with like the mole too. So let's just look at this giant number here. Okay, this is 10 to the 24th. And 10 to the 24th is essentially, okay, you have 12 zeros, and then you have 12 more of them. So you would have a trillion. So if you had $1 trillion, and then a trillion of those $1 trillion, you would have this number. All right. Okay. This number 10 to 20, it's 10 to the 24th, which is trillion, is actually pretty close to our mole number. Okay. See up here. This is 10 to the 24th. This is 10 to the 23rd. All right. So let's take a look at that a little bit. A trillion could also be written as 10 to the 23rd. 10 times 10 to the 23rd. And you can see it's kind of close to this number. So you can see that a trillion is kind of like, it's very similar to the size of a mole. Okay, so I don't, I know people probably can think of a trillion a little bit more than they can a mole, but that's just give you an idea of the size of this. Okay. Okay, so let's take a look at how the mole relates. Okay, so if I have one atom of hydrogen and it has a mass of 1 AMU, okay, so remember when you look at the periodic table, you can figure out how much its mass, atomic mass is, or its average mass is. The number up here is the number of protons. Number down here is the average atomic mass, and we take that number. For hydrogen, it's 1.0000 something. And what we're going to do, just for convenience, is round that number to 1. AMU stands for atomic mass unit. So that's the unit for atoms. So let's extrapolate. So if you had 10 hydrogen atoms, they weigh 10 AMUs. That's simple enough. If I have 1,000, 1,000, they'll weigh 1,000 AMUs. If I have 1,000,000, they'll weigh 1,000,000 AMUs. Or another way of saying that, actually, because that's just how we say it, all right? We use the words 1,000,000 hydrogen atoms weigh 1,000,000 AMUs. So you could write it out in number, or you could write it out in words. Okay, now so let's look at this giant number, 10 to the 24th, okay? So if I have this number, all right, of atoms, they would weigh this number of AMUs, which there's a 1-to-1 relationship between it, because we said that one atom weighs 1 AMU. So if I have this number of them, that's how much they're going to weigh. Okay, so writing all these zeros is kind of cumbersome, so let's just write an exponent. So it's 10 to the 24th hydrogen atoms weighs 10 to the 24th AMUs. Okay, and you could write it out in terms of words. 1 trillion hydrogen atoms weigh 1 trillion AMUs. Okay, so, all right, and you could also write it as 6.02 times 10 to the 23rd hydrogen atoms weighs 6.02 times 23rd AMUs. And remember, we can substitute this number with the word mole. Just like we can substitute this number with the word trillion. So what I can rewrite this as 1 mole of hydrogen weighs 1 mole of AMUs. Okay, don't think anything more, just stay with the logic right now. Okay, so I told you that number, 6.02 times 10 to the 23rd, is called a mole. So you can write that as 1. So instead of writing 6.02 times 10 to the 23rd, hydrogen atoms weighs 6.02 times 10 to the 23rd AMUs. You can see how hard that is to say. I'm just going to replace all that number with the name 1 mole. Okay, now here's a cool thing. Hope you got that. Okay, so instead of writing all those zeros out, I just use the word mole. Now, just like 2,000 pounds is equal to 1 ton. Okay, 1 mole of AMUs. So if you had a mole of AMUs, that is the same as 1 gram. So what we can do is replace this right here with the word 1 gram. So what we can say is 1 mole of hydrogen weighs 1 gram. Okay, it's down here, it tells you how much 1 AMU is. You don't have to worry about that. So this is really convenient here, okay? Because I could measure out a gram on a scale. And if I measure out, so if I measure 1 mole, if I measure 1 gram of hydrogen, that's the same as counting out 6.0 times 10 to the 23rd atoms of hydrogen. Okay, now let's do the same thing with carbon. So 1 carbon atom weighs 12 AMUs from the periodic table. And if we go through the same logic, 100 carbon atoms weighs 100 times 12 AMUs, or 1,200 AMUs. All right. 1,000,000 carbons atoms weigh 1,000,000 times 12 AMUs, or 12 million AMUs. So I can say 1,000,000 carbon atoms weighs 12 million AMUs. Okay, hopefully you see that. So this is 1,000,000. And there's 12 1,000,000s, so that'd be 12 million. You could go up to a trillion. So a trillion carbon atoms weighs 12 trillion AMUs. And then we can make it even more. So if I have 6.02 times 10 to the 23rd carbon atoms. Each of them weighs 12, and I have 6.02 times 10 to the 23rd of them. Okay, let's replace this number here with the word mole. So I have 1 mole of carbon atoms weigh 1 mole of times 12 AMUs, all right, of 12 AMUs, which is the same as 1 mole of carbon atoms weighs 12 times 1 mole of AMUs, or 12 moles of AMUs. So 1 mole of carbon weighs 12 moles of AMUs. Okay, now remember, 1 mole of AMUs is known as a gram. So I can replace this right here with the word gram. So I get 1 mole of carbon weighs 12 grams. Okay, so if you want to weigh out 6.02 times 10 to the 23rd carbon atoms, you have to weigh out 12 grams. Okay, sorry, if you want to count 6.02 times 10 to the 23rd, you'll have to weigh out 12. Now that's because each carbon weighs 12 times more than 1 hydrogen. So I hope you can see that even though it's the same amount, they weigh differently. Okay, so if you take a look at oxygen, all right, so now what we have is a simple relationship. If you know how much one atom or molecule weighs in AMUs, you can figure out how much a mole of that weighs in grams. So if you look at oxygen, one oxygen atom weighs 16 AMUs. So if you had 6.02 times 10 to the 23rd of them, or 1 mole, they would weigh 16 grams. Okay, and so you can, anything, you can figure that out. So if I want to count out 1 mole of carbon dioxide, okay, 1 mole of carbon dioxide, CO2. So I want to measure out, I want to count 6.02 times 10 to the 23rd molecules of CO2. All right. Well, that's impossible. You can't count them out. But what you can do is you can weigh it out. Okay. So figure out how much one molecule weighs. So one molecule weighs 12 plus 16 plus 16, or 44 AMUs. So one molecule carbon dioxide weighs 44 AMUs. All right. Now, if you want to get 6.02 times 10 to the 23rd molecules of CO2, you would weigh out 44 grams. Okay. All right. So, this is what we do, and since we have giant numbers in chemistry, and we use giant numbers, it becomes impossible to count out these numbers. And so what we end up doing is count by weighing. And this example I have for pennies, let's say you have a big barrel of pennies, and it'll be impossible to weigh all those pennies. I mean, to count all those pennies. It's not impossible, but it'd take a really long time. So what would be easier is just to measure and just weigh out a certain amount of pennies, maybe like 100 pennies. And let's say the 100 pennies weigh, it should be 250 grams. Okay, 250 grams, or 0.25 kilograms. Okay, so then what you do is then what you can do is just you can weigh the whole barrel. Okay, let's say the whole barrel weighs 5 kilograms. And then you just have a simple relationship. This is that number of pennies in the barrel per 5 kilograms has to equal 100 pennies per 0.25 kilograms. Okay, that's a relationship here. And to solve for x, and you would find that you'd have 2,000 pennies that are in that barrel. Okay. Okay, one of the things is that we don't say that we don't say 100 pennies is equal to 2.25 kilograms. We say that the 100 pennies weigh or are equivalent to 0.25 kilograms. Okay, so in chemistry, we deal with giant numbers. But the problem is the chemical equation deals with moles. So if we look at the combustion of octane or gasoline, we have this. And what it means is this. If you have 2 moles of octane, you have to combine it with 25 moles of oxygen. You'll yield 16 moles of carbon dioxide and 18 moles of water. Okay? So if you want to do this experiment, you have to measure out 2 moles of this, 25 moles of this, and you get 16 and 18. All right. Now, so how do you get to 2 moles? Well, that'd be 2 times 6.02 times 10 to the 23rd. Go ahead, count that. That's going to take you forever, okay? But what's a lot easier, because you know that the relationship between mass and number, you can figure out the number using the mass. So what you do is you use the molar mass, or how much 1 mole of this substance octane weighs. Okay. All right. So this talks about that. So let's go on. All right. So let's figure out how much 1 octane molecule weighs. So the chemical formula is C8H18. So to figure out how much a molecule weighs, it'll be 12 8 times 96, and then 1 18 times for 18. So 1 molecule of octane weighs 114 AMUs. Okay, and what we found is if you know how much 1 molecule weighs, or atom, you know how much it weighs. 1 mole weighs in grams. So I know that 1 mole of octane weighs 114 grams. So if I want to measure out 1 mole, or 6.02 times 10 to the 23rd molecules of octane, I weigh out 114 moles. Sorry, I meant to say count 6.02 times 10 to the 23rd octane molecules. I'd have to weigh out 114 AMUs of grams. Okay. All right. So if I need 2 moles, so if I want to count out 2 moles of octane, I have to weigh twice that amount. So if you want to do the math, which we want to do in the long run, one way to do is use ratios. We know 1 mole of octane is 114 grams, so we set up the ratio. Then 2 moles of octane weighs X grams. And just solve for X. All right, and we get 228. Now for the O2, let's see, I can do the same thing for oxygen. So 1 molecule weighs 32 AMUs. That means that 1 mole weighs 32 grams. So if I want to count out 25 times 6.02 times 10 to the 23rd, or just 25 moles of O2, I simply weigh out 25 times 32 grams. I weigh out 800 grams. So if I want to have if I want to do this experiment, I take 2 moles of octane, which is 228 grams of, and add it to 800 grams of oxygen, which are 25 moles, and that'll be the exact relationship between the amount of octane and oxygen I need for this experiment. Okay, now let's just talk about, let's look at it a bit more. This will get to your question, which I think we'll get to that. So let's look at ammonia. Ammonia is NH3. So 1 molecule weighs 14, because nitrogen's 14, and there's 3 hydrogens, 3 times 1. So 1 molecule of nitrogen weighs 17 AMUs. That translates to 1 mole of ammonia weighs 17 grams. Okay, so if I want to count out 6.02 times 10 to the 23rd molecules of ammonia, I simply weigh out 17 grams of it. Okay, or I use this big number and it weighs 17 grams. All right, so I'm going to go over some problems with this, and I think this relates to your question. Okay, so first one, how many NH3 molecules are in 3 moles of NH3? Okay, well, I know 1 mole of NH3 is 6.02 times 10 to the 23rd. And there are 3 moles. So every mole is this amount. So that means I have 3 times 6.02 times 10 to the 23rd, or 18.06 times 23rd, or 1.86 times 10 to the 24th molecules of NH3. Now, let me change this question a little bit. Now, let's change this guy right here. Let's change this to octane. So how many octane molecules are in 3 moles of octane? Right. Well, it's the same answer, okay? Okay, because a mole is a mole. It doesn't matter who it is. It'd be like if I had said I had 1 dozen apples, and then I had, say, how many apples are 3? I mean, I know 1 dozen is 12, and I ask you, how many apples are 3 dozen apples? You would go 3 times 12, 36. And then I go, now I have 3 dozen oranges. How many oranges is that? Well, you go 3 times 12 is 36. So this does not matter. Okay, this is just saying this will not change. Okay, because it's independent of who we have here. Okay, so we're going molecules, moles. It's independent of moles, molecules. Right, and you can write this as a ratio, okay? So there's 6.02 times 23rd molecules of NH3 per 1 mole of NH3. Okay, and I want to know how many molecules NH3 are in 3 moles, okay? And then you just solve for X. Okay, so hopefully you understood that. So it doesn't matter if it's NH3 or whatever, okay? It's always going to give you the same number for 3 moles. 5 moles of anything is going to be 5 times 6.02 times 10 to the 23rd, okay, of that thing. All right. Okay, how many moles is 4.6 times 10 to the 19th molecules? Okay, so for this one, what you need to do, so you can do different ways, but best way to do is think about it as a ratio. So I know 1 mole of ammonium, and it can actually be anything, is 6.02 times 10 to the 23rd. Okay, NH3 molecules, okay? All right, and that has to equal X moles of NH3 over 4.6 times 10 to the 19th molecules of NH3, okay? All right. Okay, and then you simply do the math, and you end up getting 7.64 times 10 to the minus 5th moles of NH3. Okay. Now, if you can think about it, you can see that this number is less than this number. Okay, so if your number was big, if you end up getting number bigger than 1 mole, you know you got to be wrong. Okay, so good idea is just think about the problem. All right, so, and it does, again, I could have said how many moles is 4.6 times 10 to the 19th octanes. All right, we're going to get, you still got the same answer, but it'd be different things. So it'd be 7.64 times 10 to the fifth moles of octane. All right. So when you go from moles, molecules, and molecules to moles, those numbers the answers will be the same no matter what the substance is. Don't use molar mass. Okay, now this is where you need to think about the relationship between mass and moles, or number. Okay, and so there is no direct relationship between number of molecules and grams, but there is a relationship between moles and molecules and moles and grams. Okay, so it turns out that going to moles is going to be an intermediate step. Okay, so what you're going to do is you got molecules, and you're going to be going to moles, and then you're going to be going to grams. Okay, and we'll show how that works in a second, but that's it. Okay, all right. So first thing to find out how many moles of NH3 we have. So we're going to figure out how many moles. So, 1 mole is 17. Okay, and then you find out how many moles is 68. Well, hopefully you can see is that it's a simple relationship. X moles of NH3 and 68 grams. NH3 has to equal 1 mole NH3 and 17 grams. Okay, and then just come up with, multiply both sides by 68, and you get that 68 grams is equivalent to 4 moles of NH3. So if I have 68 grams, it is 4 moles of ammonia. Okay, it still hasn't answered a question. Okay, it doesn't tell me how many molecules I have. It tells me how many moles I have, but now what I can do is, because I know the relationship between moles and molecules, I can figure that number out. Okay, so let's go there. So how many molecules is 4 moles? Well, every mole is 6.02 times 10 to the 23rd. You do that 4 times, and you get 24.08 times 10 to the 23rd, or 2.408 times 10 to the 24th. To get it, you can set up a ratio. X molecules over 4 moles has to equal 6.02 times 10 to the 23rd over 1 mole. Okay, so if you have 68 grams, this is 4 moles, which is 2.408 times 10 to the 24th molecules. Okay, now let's go the other way. Now let's say I want to figure out, if I give it a certain amount of molecules, how much does it weigh? So last one I went from grams to molecules. Okay, so if I have 4.5 times 10 to the 22nd molecules of NH3, how much does it weigh? Okay, I can't find it directly. I have to first find out how many moles this is. Okay, then once I do that, I can figure out how many grams, because there's no direct relationship between molecules and grams. All right, so first thing to do is find out how many moles 4.5 times 10 to the 22nd molecules is. Okay, so you can just set up a ratio. X moles NH3 per 4.5 times 10 to the 22nd has to equal 1 mole over 6.02 times 10 to the 23rd. When you solve for X, that's 0.075 moles of NH3. Okay, now you can figure out how much that weighs. Each mole weighs 17 grams. All right, So how much does this amount weigh? Okay, you can see it's going to be a lot less than 17 grams, all right? So we can set up a ratio. X grams per 0.75 moles NH3 has to equal 17 grams per 1 mole. Solve for X, you get 1.27 grams. Okay, so what it is 4.5 times 10 to the 22nd molecules NH3 weighs 1.27 grams. All right, now, so here's what you need to know. I mean, here's kind of a way maybe just to get you answers. I like to work with this, okay? So whenever you go from molecules to moles, all right, so I have molecules to moles to grams, right? So when you want to go from molecules to moles, okay, you're going to get, you're going to divide by 6.02 times 10 to the 23rd. Okay, and then what you do to get to grams is you multiply this, whatever number you get here, by the molar mass. Okay, so then we did that for that last problem. Okay, so for the first problem, we went the other way. I gave you grams, and you had to figure out how many moles, so you divide by the molar mass now. Okay. And then figure out molecules, you multiply by 6.02 times 10 to the 23rd. Now, here's key that I like to think about. Whenever you go to moles, you have to divide, okay? So if you go from molecules to moles, you divide by 6.02 times 10 to the 23rd. You go from grams to moles, you have to divide by the molar mass, which in the last problem was 17 grams per mole. Okay, and this number will be always the same, okay? And then you do when you come out of the mole, you multiply. So when you go into the mole, you divide. When you come out, you multiply. Okay, so if we look at the last problems, so how many molecules of NH3 are in 68 grams? So what I just used, so I'm going to divide to figure out the amount of moles. So divide by the molar mass. So I want to go from grams to moles to molecules. So I'm going to divide by the molar mass, and I get 4. And then I multiply by 6.02 times 10 to the 23rd, and I get that. All right. All right, for the problem 3, or the one where I started with this, figure out how much it weighs. Okay, so I'm going to go from molecules to moles to grams. Okay, so I'm going to divide by 6.02 times 10 to the 23rd. Get that. So that's how many moles I have. And then I multiply that by the molar mass, and I get 1.27 grams. Okay, so here's the thing about it is that when you find out, first of all, you have to know how much a molecule or atom weighs. Okay, and that those units will be in AMUs. Okay, and then what you can do is directly relate that to how much 1 mole of that substance weighs. So if you have one atom, a carbon, weighs 12 AMUs, that means 1 mole of carbon weighs 12 grams. If you have 1 molecule of water, it weighs 18 grams. 18 AMUs. Therefore, 1 mole of water weighs 18 grams. So students get that mixed up. Also, when you go, only use molar mass when you go from grams to moles, not molecules to moles. Grams, okay? So if a question says goes from molecules to grams, you can't do it. Okay, you have to go to moles first. And a lot of students, what they do is get mixed up here. They think that they have to divide the molecules by the molar mass to get that number. You can't do that, all right? So if you're given amount of molecules, first you have to figure out the number of moles divided by the molar mass by 6.02 times 10 to the 23rd, and then multiply by the molar mass. All right. And the other way is true also. If you're given grams and you want to go to molecules, don't use molar mass. Okay. First, the thing you got to do is figure out a number of moles, and then you figure out the molecules. All right. And remember, if you have 10 moles of any substance, it's going to be 10 times 6.02 times 10 to the 23rd. You don't have to use molar mass to go from moles to molecules, okay, or molecules to moles. You only use molar mass when you go from moles to grams and grams to moles. Do not use molar mass from molecules to grams and grams to molecules. Okay, I hope that kind of clears things up. Let me know. Ask me questions about this if you don't get it. All right. And I can give you a couple problems with this to see how this works out for you as well. Okay. But let me know how this goes. So let me know if you have any questions about this. Then I'll get you some